Galaxies appear calm and stable. Their stars remain in orbit. Their spiral arms hold together. Then astronomers begin measuring how fast those stars are actually moving. Far from the bright centers of galaxies, where the visible stars and gas become thin, the outer stars keep moving, not a little too fast, far too fast for the gravity of everything visible to keep them bound. That creates an immediate problem. A star moving that quickly should not remain comfortably in orbit. The farther out it is, the less visible matter there is to hold it. Yet the stars do not scatter into space. The galaxies do not come apart. The motion continues as if an enormous source of gravity is still present. The measurements remain. The galaxies remain. But the inventory fails. Everything visible through telescopes should account for the gravity being observed. Instead, the numbers stop matching reality. For the first time, it becomes possible that the universe already contains far more mass than anyone can see. If that missing gravity is real, then where is the missing matter? Maybe the first galaxy was unusual. Maybe the measurement was wrong. A hidden error in the instruments. A mistake in the calculations. A local problem affecting one observation. That possibility survives exactly until astronomers start looking elsewhere. They measure another galaxy. The same mismatch appears. They measure another. Again. The stars at the edges keep moving, as though more gravity exists than telescopes can find. The search expands. Different galaxies, different shapes, different distances. The pattern refuses to disappear. What began as a single contradiction starts spreading across the sky. Every new measurement removes another escape route. If one galaxy behaves strangely, that is an anomaly. If galaxy after galaxy behaves the same way, the anomaly becomes a pattern. And the pattern does not stay confined to individual galaxies. Larger cosmic structures show the same imbalance. Visible matter and observed gravity continue refusing to agree. The consequences become harder to ignore. The problem is no longer finding a mistake in one observation. The problem is that the same missing gravity keeps reappearing wherever astronomers look. The explanation that once seemed safest begins to collapse. What looked like a local measurement problem now reaches across enormous regions of the cosmos. Something unseen appears to be influencing how the universe is organized. And if that invisible matter really accounts for the missing gravity, there is still one question left. Can the universe finally balance its books? The idea survives something every alternative explanation failed to survive. It keeps matching the observations. Galaxies that once looked unstable suddenly hold together. The rapid motion of distant stars no longer appears disconnected from the mass around them. The mismatch between what is visible and what gravity demands begins to narrow. Then the idea is tested on larger scales. Researchers build models of the cosmos that include this invisible component, and watch what happens. Structures emerge that look far more like the universe astronomers actually observe. Galaxies gather into familiar arrangements. Large cosmic patterns begin appearing where visible matter alone struggled to produce them. For the first time, the missing mass problem seems manageable. Galaxies behave more like the observations. Large cosmic structures begin resembling the universe astronomers actually see. The inventory finally appears close to balancing. For the first time, the missing gravity problem appears close to solved. Then they ask a larger question. Not how galaxies move, how the universe itself evolves. To answer that question, they turn toward distant exploding stars. Those explosions provide a way to track how the universe has expanded over time. The expectation appears straightforward. Gravity pulls matter together. A universe filled with matter should still expand, but the expansion should gradually lose speed. The farther astronomers look into the past, the more they expect to see evidence of gravity slowing everything down. Instead, the measurements move in the opposite direction. The distant explosions appear in places that should not exist in a slowing universe. Again and again, independent observations point toward the same conclusion. Expansion is not losing speed. It is gaining it. The universe is not merely resisting gravity. It appears to be accelerating away from it. The consequence arrives immediately. The repaired inventory survives the missing gravity problem. It does not survive the expansion problem. The missing gravity problem had appeared manageable. The universe looked as though it could be explained by adding vast amounts of unseen matter. But now the larger system refuses to cooperate. Even after accounting for enormous quantities of invisible mass, reality still behaves differently than gravity alone predicts. The contradiction spreads beyond galaxies. Something else appears to be influencing the cosmos. The universe is no longer missing only matter. An additional unseen component now seems necessary. And if both visible matter and invisible matter are still not enough, a larger question begins to emerge. How much of the universe can actually be identified directly? The final picture looks nothing like the one people started with. Astronomers add together everything directly visible: stars burning inside galaxies, clouds of gas drifting through space, planets, dust, and every other ordinary form of matter that telescopes can observe. Then they compare that inventory to the larger cosmic accounting. The visible portion shrinks, not by a little. It collapses into a small minority of the total cosmic budget. Modern cosmology concludes that ordinary matter represents only about 5% of the total cosmic energy budget. Everything familiar, every star in every galaxy, every planet, every mountain, ocean, and human life belongs to that small fraction. The consequence is difficult to avoid. What humans see is not the main substance of the universe. The bright universe visible through telescopes is real, but it is no longer the dominant part of the cosmic picture. It is a trace. A visible layer revealed against a much larger background, inferred through gravity, expansion, and their measurable effects. The search began with stars moving too fast around galaxies. What looked like a problem inside a few galaxies expanded into a problem with the universe itself. The stars, planets, gas clouds, and galaxies people can directly observe remain real.
Ordinary matter occupies surprisingly little of
They are simply no longer the main story. Modern cosmology suggests that most of the cosmos is made of components humanity has never directly identified. The universe people thought they were observing turned out to be only a small, visible fraction of the universe that actually exists.